Right, in this video we're going to have a look at calculations. So I've got relative formula mass, which is MR, and I've got percentage by mass, and these two go hand in hand together. We're going to start with MR, alright, so if they ask you to calculate the relative formula mass of C4H8, they will give you these numbers. The 12 is the mass of carbon and 1 is the mass of hydrogen. You can find them on the periodic table, but they will give you it in the question. And to calculate MR, all you have to do is add up these numbers. So there's 4 carbons in the formula, so you're going to have 12 and 12 and 12 and 12, so 4 12s. And then you've got 8 hydrogens, which means you need to have 8 ones. Now I'm writing this out, rather than writing 12 4 times, I'm just going to do 12 times 4, and then rather than writing 1 8 times, I'm going to do 1 times 8, alright? But it's really important that you are adding those numbers together. So you work out carbon, you work out hydrogen, then you add them together and you get 56. Now, if you're asked to do percentage by mass, you're going to use your answer 56, okay? They could say, what's the percentage by mass of carbon in C4H8? And what that means is how much of C4H8 is actually carbon by mass. So we can see that the carbon, you've got 12 times 4. So I put my 12 times 4 on the top line, and then on the bottom line, you put the entire mass, which is going to be your final answer of 56, okay? So that's going to give me 48 over 56, and I just get that as a percentage. I divide and I times by 100, and I get an answer of 85.7. So that tells me that this mass here of 56, 85% is because of the carbon. And you can do exactly the same for hydrogen if you wanted to. You could get the percentage by mass of carbon in of hydrogen in C4H8. Alright, and we can see the hydrogen part is the 8 times 1. So that would go on my top line, 8 times 1. The bottom line is the whole thing, so it's still going to be 56. Times that by 100. And I get 8 divided by 56 times by 100, and it's working out there as 14.3%. All right, so you can see adding these two percentages together gives you 100. 85% of the mass is because of the carbon, but the other kind of 15% is because of the hydrogen. Alright, so if we look at another one, H2SO4, the first thing I'm going to do is calculate the MR. Alright, I've got 2 hydrogens in my formula, so that's going to be 1 plus 1. Hydrogen has a mass of 1. I've got 1 sulfur, that's going to be plus 32 because that's the mass of S. And I've got 4 oxygens, so I can write 16 4 times, or I can do 16 times 4. Alright, so that part is my hydrogen, that part is my sulfur, that part is my oxygen, and I'm adding those parts together, and I'm getting a total answer of 98. If I wanted to get the percentage by mass of hydrogen, okay, in H2SO4, the hydrogen part was 1 plus 1, that's on the top line, my bottom line is 98, and I times that by 100. If I cared about the sulfur in percentage by mass, I'd put the sulfur on the top line, 32, the whole number on the bottom line, 98, times by 100. If I cared about the oxygen for percentage by mass, it's going to be 16 times 4 on the top line, 98 on the bottom line, times by 100. Slightly harder example, I've got calcium hydroxide, and it includes a bracket, alright? So when you're calculating formula mass, it's really important that you can read the formula, alright? This formula tells me I've got 1 calcium, alright? It's not inside the bracket, so I don't multiply it by the 2. And calcium has a mass of 40, so that's going to be 40. Oxygen is inside the bracket, and there's a 2 outside, and that tells me I've got 2 oxygens. Now each oxygen has a mass of 16, so that's going to be 16 plus 16. Similarly, hydrogen is inside the bracket, so I've got 2 of them. Hydrogen's got a mass of 1, so that gives me 1 plus 1. And when I add that all together, I get 74. If I was doing percentage by mass, it's exactly the same. If I cared about calcium, calcium was 40. So I put 40 on the top line, 74 on the bottom, and I times by 100. If it was oxygen I cared about, there are 2 oxygens in the formula. So I've got 16 and 16 on the top line. The whole thing is 74 times by 100. And if it was hydrogen I cared about, I've got my 1 plus 1 over my 74 times by 100. Last one is just, again, more brackets, a slightly harder formula to read, all right? Process is the same. If I want formula mass, aluminium, I've got 2 of them. Each aluminium is 27, so it's going to be 27 plus 27. Sulfur is inside the bracket. There's a 3 outside the bracket. So I've got 1 in there, 3 outside. 1 times 3 is 3. So I've got 3 sulfurs. Each of them have a mass of 32. So I'm going to do 32 times 3 instead of writing it out 3 times. And then with oxygen, you can see you've got 4 oxygens inside the bracket and then a 3 outside. And just like in maths, brackets mean multiply. So it's not 4 plus 3, it's 4 times 3. You've got 12 oxygens in total. Now we can see here that oxygen has a mass of 16. So it's going to be 16 times 12. This I'm going to need a calculator for. 16 times 12 plus 32 times 3 plus 54, and I get an answer of 342. If you were doing percentage by mass, exactly the same procedure. I've got 2 aluminiums, so if I cared about aluminium, I would do 27 times 2 all over my total of 342 and times it by 100. If I wanted the percentage by mass of sulfur, my sulfur part was 32 times 3, so it's 32 times 3 all over 342 times by 100. And if it was oxygen I cared about, my oxygen part was this, 16 times 12 all over 342 times by 100. So the bottom line is always going to be the same. You'll always multiply by 100, and on the top line you just take the part that is relevant to that element.